Continuing on with chapter 5.1, we're going to look at the next two objectives, computing probabilities using the classical method. That would be one outcome right here, the classical method. And then the other objective is this idea of subjective probabilities, but that's just a quick little notation. So that's what we'll finish this 5.1 lesson on. And so the classical method, like kind of the more traditional way we do probability, and another word for classical, just again in case you're looking at other places for help, another word for classical, you may see this word theoretical, theoretical probability. That would be, and that is just the number of ways we know an event can occur divided by the total number of outcomes. For example, the probability of flipping a coin and getting a heads is equal to 1/2. There's one way to do it out of two total ways. That's kind of the traditional way. So another way to look at this is if S is the sample space of the experiment, the number of ways an event can happen divided by the number of outcomes in the sample space would be the division that we do. These are, again, the same ideas in terms of just using a more formal language of sample space. So that's what we're looking at there. And so looking at some examples using the classical approach, one is with dice in gambling are very common ways to look at probability. There's a lot of other ways, but this is kind of a traditional way. And so what you're looking at here are all the different possible outcomes of rolling when you roll two dice. You can see all the possible outcomes here. 1, 2, 3, 4, 5, 6. 6 times 6, there are 36. There are 36 outcomes within here. Okay, each outcome is equally likely. The possible outcomes of this experiment are drawn here. So what's the probability? What's the probability of rolling a 7? So the probability of rolling a 7, we count them up and I see 1, 2, 3, 4, 5, 6. There are 6 ways to get 7 out of 36, which would be a 1 out of 6. And then of course you could change that to a decimal value. What's the probability of rolling snake eyes? Snake eyes is the probability of rolling a 2. That's what snake eyes is. They look like snakes there. And in this case, the probability of rolling 2 is equal to 1 out of 36. And again, you might want to convert that to a decimal value. And then what's the likelihood of rolling a 7 versus rolling a 2? So we have this one. What's the rolling a 2? You can see the difference. Rolling a 7 is more likely, right? Or more likely, and exactly we can say it's 6 times more likely to happen. Okay, so that's one way we look at this. Is the classical approach to probabilities. You count the number of ways something can happen. And then the last probability, we don't want to do any calculations on, but you want to be aware of it. It's called subjective probability. And so the subjective probability of an outcome, and this is the one that most of us use, and we could get a lot better at it. Let me erase that. The subjective probability, it's based on your judgment. Subjective probability of an outcome is obtained on the basis of a personal judgment. And so just knowing from your experiences, you make decisions, you determine the likelihood of some event based on some subjective. And that's actually the one that you use most often in the world. You're making those. And what we find out is we're not very good at that because we usually use incomplete data. But we'll talk about that in class.